It's time. And I think everybody's in. Well, kind of.
How come? Oh, okay. Works.
Yeah. Organizer people, do we want to give them a few more minutes, or do we just want to start? The lights are still on. Feels very... I feel like I'm in a movie theater. The lights have to go off at some point. Okay.
Okay. I guess we can get started.
Yeah, we have a lot of fun stuff to do, so we might as well get moving. We'll try and get through as many as we can. And I'll let Nermin kick it off.
Okay, so hello everyone and welcome. This is Andrew.
And that's Nermin.
Hello. And we're going to try to get you puzzled today by showing you some code snippets. We have 8 puzzlers prepared. We'll see how far we go. Before we actually start, a couple of housekeeping items. Obviously, thank you for having us here. And I wanted to give credit to Jason Zog and the REPL HTML that we're going to be using to run the code from the browser. So that's the URL if you're interested in this kind of stuff. And a bit of a, well, first of all, I'd like to thank, obviously, all the people who've contributed to Scala Puzzlers as well. That's the only thank you I'll do. Quick question here. Who's been to a Scala Puzzlers talk before, by the way? Oh, okay. They're all new puzzlers, don't worry. Totally coincidentally, my name, the fact that something that looks like my name is on the cover has nothing to do with it. This book is about to come out. It's out in preprint. It's clearly the best book about Scala that ever has been written or ever will be written. And I highly recommend that you buy at least 4 or 5 copies just to be safe. You know, you might spill some coffee on one, or you want to give one to a friend. So, you know, redundancy is good. We learned that in software development. No, seriously speaking, I think Nermin and I both, when the book, when we were working on it, we were wondering, well, the website's already there. What else is there? And I think we both discovered that it was a very, very interesting learning experience. You know, we go into lots of very interesting discussions and details. I think there's no greater compliment than to have someone like Bill Venners, who was editing the book, saying, you know, he learned new stuff about Scala by editing the book. So I think, well, humbly, I would say, I highly recommend it. Cool. So we always kind of try to cover what is actually considered a puzzler. So just very quickly, it cannot be a bug. And it cannot be something that is like fairly intuitive. You have to have at least like a decent knowledge of Scala to be kind of puzzled. So there are obviously some which fall into the gray area, but we try to stick to these rules. And of course, it will be more fun if you try to guess as opposed to having a REPL in front of you and running the code. Which you could, of course, also do, but please don't. So with that, let's go to the first one, called Stringy Conversions. So in case some people that don't see in the back, we recommend... what's that magic Apple key again? There we go. I'm going to give it a try, but... I'm not sure that works with REPL HTML. So what we usually... we retract our thanks to Jason Zog. We don't thank you anymore. What we usually recommend is if you don't see, like, move back. There are plenty of seats here in the front. Because, yeah... and now we pause the presentation while half the audience decides to come further down. Sorry about that. While that is happening, I'll just try to quickly go through. So... obviously, we have 2 classes. They're implicit values declared in slightly different ways. And we're trying to subtract, it looks like a string from an int from a string. And then we just create instances of these classes. So the question is, what does this code do? And maybe to be a little more obvious than Nermin was saying, they're actually almost exactly the same. The difference in the case of B, as you'll note, is that there is a type attached to the implicit. So the implicit conversion is just about turning a string to an int. It's the same conversion in both cases. And here are your 4 options. So we'll leave a little bit of time. Yeah. Does everybody understand? Are there any questions about the code or the answers? All right.
we'll have to repeat the discount code for all the people who came late.
Okay. So how's everybody doing? Are we kind of ready? Have you figured out, chosen your favorite answer? Okay. So how many people think it's number one? Just a quick show of hands. Okay, a few people. How many people it's answer number two? Also a few. Interesting. People. Answer number three? A little bit more, almost like more than half, I would say. And answer number four? No
and
one.
there's still a lot of people in the audience who don't have arms. That's also okay. Don't worry, your boss doesn't get to see this. This is not like a job interview. Don't get fired for voting wrong.
So let's see what it actually does. Let's run the code. And it was the answer number two, those few people that got it right. So essentially, what happens here...
Wow, by the way. Duh. It's amazing.
So essentially what happens is the first one just works fine. There's implicit conversion defined in string ops class, I believe, that will just totally correctly convert this to int. So this will be 2. But the second one, the reason it gets into the infinite loop and is that the type is known here up front. So when it considers the implicit conversion, it now has 2 candidates. It has the one from the string ops, and it has its very own. So basically, it just gets into the infinite loop. This was, I believe, posted on the mailing list, and basically the recommendation was, there were a couple, but especially the one from Miles saying that don't do this, don't try to define implicit conversions on these like primitive values because you run into a risk of running into this kind of situation.
Is the answer clear to everyone why this happens, by the way? See lots of puzzles. Basically, the toInt operator that we're applying here doesn't exist on string. Yeah, it's Java lang string. So the only way to get the top one to compile is to apply the standard conversion Nermin was referring to, which is in string ops, to turn that underscore into a string ops, and then you can apply toInt, no problem. In the second case, we have the same problem. We have a string, and we try to call toInt on it. Now, the problem is that there's another conversion that we have in scope, which turns it to an int, and that is the implicit that we're actually in the business of declaring right here. So instead of calling string to string ops to int on that, it calls string to int on the underscore, to int on that, and that causes the endless loop. And this, to me, the thing that's interesting about this is that normally we say, well, it's nice to have explicit types because it helps the compiler and it's clearer and easier to read. And this is a case where implicit types, or being explicit about the types, actually blows you up. All right, so this is a little bit longer. So let me try and walk through this code a little bit. So what's the purpose here? We're basically, there's a long story in the book that you can read. We have a mother, and then there's a lunchbox, and she's trying to see whether her son is or daughter is taking healthy food to school. And so she basically sees, she puts an apple into the lunchbox and then sees how many items are in there. So basically, the idea is that we have a first def that takes this lunchbox. It's a mutable set. I know that's evil, but let's ignore that for now. And it starts out with a set, and then you add an item to it, and then you return how many items are in the set. And then you think about it, and then, well, actually, set is not necessarily the best representation. Why shouldn't it be a collection of, or iterable of any type? And so that's the only thing you really do in the second one. You refactor it ever so slightly to be an iterable, but the rest of the code remains the same. And then you call all of them. And afterwards, you actually also see how many items really are in the lunchbox. And here are your 4 choices. Tick, tock. It's the same lunchbox, by the way, right? So we define the lunchbox once, it's a mutable set, and then we call both functions on it. Ready or not, here we come. Who thinks it's number 1? 3 people. The problem with puzzlers usually is that we generally include the obvious answer, and sometimes it's right, but of course, this being puzzlers, you have, unfortunately, a kind of hint. Who thinks it's number 2? Who thinks it's number 3? And who thinks it's the crazy one?
Okay.
So for those people who voted for the crazy one just because it's the crazy one, good for you. Let's have a look. Huh? So, yeah, I guess the answer is pretty obvious. The magic, the evil, the horrible, any to string add.
And actually, as you mentioned, well,
Yeah, go on.
why don't you go explain it? I'll show it later.
Well, I think a lot of people, the groans kind of indicate to me that a lot of people got this as soon as the answer came out. The problem is that plus obviously exists on sets, but it doesn't exist on iterables. And in order to be evilly consistent with Java in all its evilness, you can actually add a string, which we of course constructed the example so they really are strings, to anything. And what does it do? Well, what it does is it converts the lunchbox into a string, which turns into, set. It's 30, I don't know, 30-something characters long. I think Nermin has it somewhere. And then you print the size of that. So really what the second thing is returning is the size of a string rather than the size of a collection.
Right, and what I was going to show is if you don't want the any to string add to get applied, the obvious way is to prevent that from being imported. So you would write. It doesn't work in the REPL, but in a regular file, it just has to be the first import, I believe, in the class. So you would say something like.
And this is really interesting. This is one of the more interesting things to come out of this puzzler is you can actually prevent it. You can switch off any to string add, which arguably is a good thing to do in any case. Right. And then you have to have this weird syntax, and it's more complicated than that because it really has to be the first statement in your entire program or something. If you look at the puzzler on the website, it has a bit more details. There's a long Stack Overflow thread that describes this. But basically, yeah, you can unimport any to string add, and then you need that underscore at the end to make sure you don't kill the rest of predef, which you probably want. A final point, by the way, nothing actually ever gets added to the lunchbox. Plus does not add to a mutable set. Plus, I think, adds to a mutable set. There's a question. Yeah? Huh? Yeah. Oh, it's by the Word Remover. Yes, yeah, okay, excellent. So, yes, I'll shout out Word Remover. And, remind me if I don't put it in on the website. It sounds a good one to shout out. All right, Nermin, over to you.
Cool. Let's move on. I just have to get out of this. Okay, want to skip a few. So, what are we doing here? So, excuse me. We're dealing with very short sequences, and we're calling permutations method on it. I assume it's fairly obvious what permutations will do. Shall we reveal what is the Shall we reveal what is the structure?
Sorry, I'm busy with a fashion shoot here. I have no time for
I figured
for the talk.
I figured. So, anyways, I think it would be a nice hint to say that when you call permutations, it actually returns an iterator.
Yeah, sure. I mean, the permutations. What permutations does is, yeah, it returns the permutations of the input set. So in the case of 1 and 2, you can kind of imagine what that would be.
So we're just dealing with 2 of those, trying to call some method on it, and basically the question is, as usual, what is this code doing?
So to be specific, this is just a refactoring. The one that I always apply, I always like to call is empty because I think it's clearer and easy to read rather than length greater 0, which is a size check. Anyway, keep going.
Okay, so I'll have to scroll this a little bit. Yeah, I guess this would work if it's. So here are the 4 choices.
There's discussion in the room, so some people think they have an idea what's going on. That's very good.
Okay.
All right.
Shall we collect the votes?
Let's go collect the votes.
Okay. Quick show of hands. Number 1.
This one is for a job interview, so you better get it right. Number 1.
Who thinks it's number 1?
3 people.
Okay.
Number 2.
So
Number
a
3.
little bit more.
Number 4.
Wow.
Who's
Nice.
awake? I see. I think Nermin, our friend Nermin, was rather generous with our hint there.
Okay.
Yeah, Nermin. So congratulations to most of you who got that
Yes.
one right.
So essentially, the entire trick is that the iterator is mutable. It keeps state, and the Scala docs explicitly mentioned that there are only 2 methods that you should really be calling on in an iterator. And if you call any other method, you shouldn't be calling any method after that. So what happens just to go quickly, what happens in the first one, we're actually violating that rule and calling length, which exhausts the iterator. So there's actually nothing to print. And then in the second one, we're calling isEmpty, which behind the scenes is implemented via hasNext. So that doesn't violate the rule, and it happily just prints the permutations of 3 and 4.
So, I mean, we are violating the rule. We just get lucky because isEmpty happens to be implemented with, if you implemented it a different way, this could blow up as well.
Right.
But
So
that's how it happens.
be careful with the iterators, I guess.
And and I mean, so you could fix this if you like. I guess you could put a 2sec, for instance, at the end of the 1-2 or something like that, so you can convert it obviously to a type that doesn't suffer from this problem. But the key to this puzzler, as Nermin said, is to know that things like that return an iterator. So basically, watch out for iterators, really. All right. I love this one just because I love the title so much. So a few dollars more, a list full of dollars. We had a long discussion around this one. So let me just talk through this one a little bit. We define, because we're talking about dollars, but dollars in this case, we're going to model them as ints. And then we define a constant, $1. It's kind of about as much as I have with me right now after the flight over. And then we have a list of dollars, a list full of dollars, 1, 2, 3. And then we use, so these are exactly the same statements for those who can't see it exactly. They're just, the top one has curly braces, so it's a map, a into dollar with curly braces. And the second one is a map, round brace, a into dollar. But otherwise, so there's nothing else that's different between the two. Nermin, let's have a look at these sample answers. And we're going to get through all 8 if we go at this pace. Doing pretty well.
That's good.
That's excellent. It means we run out of wiggle room. We'll just have to do a longer fashion shoot at the end. You can hear by the noise level, there's clearly some people conferring. Teamwork is actually, I'm not sure whether we should call that cheating or not, but for those of you who are doing teamwork, no, that's all good. All right. Yeah, well, yeah, come on. Let's force a vote. Who thinks it's number 1? Wow, people are ignoring the obvious ones now. Ugh, the obvious answer. Who thinks it's number 2? A bunch of people. Runtime exception. Who thinks it's number 3? Huh? Number 3. Oh, it's kind of even between there, 2 and 3. Who thinks it's number 4? And there's a bunch of people who think it's number 4.
Okay, so it's kind of even distribution between.
It's pretty even distribution.
2,
and
3, 4,
yeah,
except 1.
I mean, smart move. Basically, ignore the obvious one and then go a kind of 33% split on the remaining options. But those of you who voted for number 2 in this case actually get it right. Wow. So the interesting one for me is, well, what on earth is going on here? And this,
statement from Nermin does a good job of explaining it. Basically, certainly when I was introduced to curly braces and round braces with respect to functions, you kind of get taught that they're the same thing, really. And it's really a matter of style whether you like one or the other. And that's not true. What is true is if you look at the Scala spec, is that curly braces, well, the body of a curly brace is what's called a result expression. And the body of a round brace is what's called an expression. And they differ in one small aspect. The first part, the variable of a result expression, can contain a type ascription. But that is not true for an expression. Which means that the way these two particular statements are parsed is that in the first case, with the curly braces, a:int, the int is regarded as belonging to the a. And it returns $1. So that is a function that takes an int and returns 1. Because $, is a constant, which has the value 1. And that is why it doesn't matter what we put into list, it just returns 1 every time. The second one is a little more interesting. Int is not allowed to be the type ascription to a. So what else can it be? It can be the type ascription to the entire thing. So a is the actual, the function itself. And that works because a is a list. And the list is a function from int to int. But because int is $1, it's also a function from int to $. So what is happening here? We're basically mapping a to itself. And why does this go wrong? Well, the first time round we call it, we map a, the first element is 1, so we get the second element rather, the element at position 1. That's fine. Then we call it for the second map iteration, that passes in 2, which gets the third element, and then we call it for 3, and that blows up with an index out of bound exception. So if this list had happened to be 0, 1, and 2, it would have worked just fine. And it would have returned 0, 1, and 2, list 0, 1, and 2.
So
there we go.
Just wanted to show it. So obviously, if you want to go with that, the way to fix it would be to put parens around this so that you're a little bit more specific.
And now we run it.
And then if we run it,
ta-da!
It works as expected. Okay. Let's move on. The devil is in the defaults. For those of you who attended Martin's keynote, there was a question about this actually after the keynote, so that might give you some hint of what is going on. But essentially, just to walk through, so keep in mind we are working with a mutable queue here, and we have two methods, goodies and baddies, which essentially construct a map with some default values specified in two different ways. And then we try to pass some string in to basically get the element from the queue. And the question is, what does the code do? So here are the options.
So the background for this was, by the way, it's kind of a simulated one of these games where you go from room to room and you sort of look in places. And of course, you want to have a sensible default. You don't want to have to initialize everything with like default values where there's nothing. So for those places where you haven't set up anything yet, you want to have a sensible default, which we have here. So your choice is really, does it blow up? And if it blows up, when does it blow up? I see the guard of people at the back is growing again, the standing guard.
Okay.
Right, show of hands time. Who thinks it's number 1? Oh, bunch of people. Who thinks it's number 2? Uh-oh, now that everybody's like, oh my God, the people who all voted for 1, I can't vote anymore. Who thinks it's number 3? A few people.
Okay.
There you go. Good for you. Who for instance number 4? Yeah.
Okay.
Go for the obvious. Well, maybe. No. Nermin, go ahead.
So it seems like most of the people got this right, sounds like.
Indeed.
Let's give it a try. So essentially that was answer number 1. Just said most of you got it right. So what happens is the big difference is that we provide a function here which will get evaluated every time. But with the default value, you just provide it once and it's shared across. It's basically not instantiated or evaluated every time. So by the time we get to the last one, we actually exhausted all the elements from the queue, and it just throws a runtime exception essentially, because it already dequeued that one element that it had. Does it make sense?
Yeah, to me, this is a little weird because you would think of a default value as being like a sort of factory or a constructor for the value. Seems like a nice, obvious, the top one seems a little wasteful because you don't need the key. With default, takes a key as the underscore there is the key of the map that you're asking for. So if you have something where you need the key, like, I don't know, you compute a default value of bitcoins based on somebody's age or whatever, then that makes sense. But if you don't need it, with default value seems like a nice, obvious option, but it's actually pretty dangerous if you're having a mutable element that you want as the default. So don't do that. There are the original thread this comes from, if you look at the link, the source. There is another way of doing it. You can override the function. There's some function deep down in the map internal. So if you pass your own value of map, you can basically convert it to a factory. But I would say, yeah, just stick with the former syntax. All right. Ah, yes. Yes. Back to the days of Java. The return keyword. And we had a long, as part of the editing, so the chapter in the book is particularly interesting because we had a long back and forth editing about whether there is a single good use case for return in Scala. So you'll have to buy the book to find out what no. But anyway, what's happening here, right? So we're calling and Dominic can't answer because I think he knows the answer. We define a method, value. It returns an int. And then within this value, we define 2 kind of helper methods, 1 and 2, both of whom turn an int to an int. And they have a return statement in them. Let me say as much as that. And then the actual return value of the function is calculated at the bottom there, 1 plus 1 of 2 plus 2 of 3. And then we try to figure out what that's going to be. And here are your sample answers.
I think so, yeah. That's cool. That's cool.
So people following it with their fingers. Which one? Where is it going to go? What's it going to call when it gets to this point? Next time we're going to have some kind of annoying music to distract you halfway through. That would be really evil. And by the way, as a heads up, it looks like we're going to be excellently on time, so nobody has to worry about getting lunch. You're going to be first in the queue, which should be the main reason to vote green on your little pad. But we're not going to make you run over. I've been at conferences too many times. I know how this game works. All right. Who thinks it's number 1? 3. Who thinks it's number 2? 4. Who thinks it's number 3? 6. Who thinks it blows up?
Okay,
There we go.
That's pretty even, I would say.
That's a pretty even thing. And we still have a few armless people in the audience, but that's okay. They're waking up. All right. Let's run it.
The moment of truth.
The moment of truth. It's good for you who voted 3. So Maybe we should do this next time. We'll ask one of the people who voted 3 to actually explain it, rather than just saying, "Oh, I'm just going to vote A every time and see."
Yeah.
I,
But in that
25%, statistically speaking, I should be doing okay. So yeah, no, we have a few people who can explain. It's not that crazy. So what is happening here? Well, the return keyword in Scala. What does the return keyword do? If you look at the definition in the Scala language specification, it says it will take the value that you pass to it and return it as the value of the outermost, the innermost enclosing method.
Yes.
Yes. So, what does that mean? Well, what in this case is the innermost enclosing method? Well, it turns out to be value, if I remember.
Well, in case of method
One,
it's basically when it returns from here, it's this method. So it basically
one.
returns from 1.
Yes, because it's a def. And the second one, the only difference, of course, is that that's a function value. It's an anonymous function value, but not a def.
So,
But an anonymous function value does not count as an innermost enclosing function. That means that for that second evil return statement down there, the innermost enclosing function is value. So what happens when you run the code? Well, it obviously parses the first 2, and then it gets to that last line, 1 plus 1 of 2. So it calculates, it goes 1, that's very nice. 1 of 2 is return x 2. So that's 3 at this point. And then it goes 2 of 3, and then it reaches the return x and goes boom! That's the return value of the function. And it totally ignores the 1 plus 1 of 2 bit, and it returns 3 as the result of value, which is fun. The other thing worth noting is that unlike some other languages, Scala does not worry about the fact that there is unreachable code in these 2 returns at the end of these. Scala does have an unreachable code error, but that has to do with pattern matching. That does not have to do with this particular case. It'll warn you. It'll tell you there's stuff that you can't get at, but it will compile quite happily.
yeah, so those 2 values are just ignored. They're really just inserted to kind of spice it up, I think.
Yeah, of course. And the other thing, well, thank Dominic for that. He came up with this.
Right. So
The other thing that's worth noting here is that, of course, under the covers, this is actually an exception. There's a throw of a non-local return exception going on here, and you can do really fun stuff when you catch those, which the compiler really tries to tell you, please don't do this. Don't do this, but you can force it to, and then fun stuff happens. Anyway, next one.
Next one. Before I move to the next one, how many people attended Simon's talk yesterday on simplifying Scala? A very, very good talk. Okay.
So,
So you'll
I hope you were asleep during this next portion.
No, so you already have a hint from Simon. We still wanted to include it because there's some interesting aspects from it. But so yeah, I think it's pretty straightforward. We construct a list, try to convert it to set, and then add element 3 as a string. And
Remember
the question
from our earlier puzzler, it's a set. So plus does indeed work on sets. The answer is not 36 again this time.
and we just try to print that value. So here are the options.
Yeah, no, do you have one of those screen magnifiers? I know that the plus doesn't work there, but I think people at the back. Yeah, something like that. I'm not. Okay. Jason's going to get a ton of pull requests on his. It's like, please make it work with Zoom. Use different code highlighting. Bill, no cheating. It's just private cheating. Okay, let's have a show of hands. The ones who are in Simon's talk can't vote. Who thinks it's number 1? The obvious one. Excellent, somebody's brave enough. Who thinks it's number 2? Good. Who thinks it's number 3? Who thinks it's number 4?
The wisdom of crowds wins out again. So now, Nermin, let's take us through the explanation of why it does indeed
Sure.
print.
So I'll still run it just to show. But also, the reason I wanted to run is to show the warnings. So essentially, what happens here, there's the auto adaptation of arguments. But let's walk through it. So the method toSet doesn't take parameters. So when we put the parens here, it actually treats it as a call to apply, which in case of sets. So
you want to rewrite it line by line? That actually helps. If you
sure.
add the first.
It's equivalent. It's.
Oh my God! Puzzled by my own puzzler. I was like, oh.
Yeah. No, in all fairness, there are multiple things going behind the cover. So, but anyway, so with the apply is treated as the contains method on set. But the question is, what is it trying to see is contained in that set? Because in the resulting set. So the set will contain strings. So then, as a last resort, compiler inserts this unit value and says, okay, otherwise it wouldn't compile, but let me try with the unit value. And with that, it actually works, but infers a type as any, because that's the only super type of string and unit. So we end up with a set of any containing those two strings in the unit value, and then we just add 3, and that gets
actually,
converted.
it doesn't contain the unit value, which is why it prints false.
Right. Sorry. Yes. So that, and I just wanted to add here that the reason, like Simon showed this yesterday, and obviously auto adaptation of arguments is not something that is desired. The reason it ended up that way is I think the idea was to allow to pass tuples without actually explicitly typing the parens, so that the compiler will just put those parens for you. But in case if you don't provide anything, it just tries to create still an empty tuple, and that's the side effect of this.
So it's actually not really designed to do a unit. It just happens to be the fact that an empty set of parens is the unit value. But maybe, Nermin, if you just write out what this actually becomes.
Sure.
So what is really happening.
Here it is desugared. Let's put it that way. So this will say numbers equals list.
So then you get
toSet, and we're gonna be explicit about the
apply.
type.
Yeah.
And then it's gonna call apply,
which is contains on the set.
Right, and it's gonna
pass.
this.
Exactly. So the empty brackets doesn't work because apply needs an argument, so it shoves in another set of empty brackets, and. No, but that doesn't work because you can't call apply on a set of string with a unit.
No, the inferencer infers on the entire statement. So it says, okay, I have strings and I have unit, and it figures out that, well, the type must be any then.
Yeah. So the toSet can change the set of the resulting set depending on what else it needs to do further on. It's impossible to break this down. We tried for the book to chop this up into individual statements so that the compiler, you could see it step by step, but it doesn't work. If you try to get the bit before the apply out into a separate value, then you can't, you have to force it the way Nermin is doing this here.
Yeah, so there.
The list of any. Oh, you mean it actually turns the list into a list any so it can call it. I mean, yeah. Someone Google ScalaDoc, please. No, we'll find out. The other thing, by the way, worth pointing out here is there is also a to method. So you can call .to. Maybe you could just desugar that one, and that is probably the better way of solving this because that does not break in this particular way.
So if I remember correctly,
it's .to, and then you pass the type, I think.
Something like this.
I think it's in square. It's in square brackets 2, and then square brackets, and then just set.
Like this?
Yes, exactly. Right. And that will not break in this evil way. All right. The last puzzler, and then lunch. So we've actually made it through all of them. Excellent. What's in a name? What is going on here? Just a quick summary. So we have a class, C, and it defines a method sum, and that method sum has a couple of named default arguments, and it just sums them, x and y. And then we have a method that extends C, or rather a class that extends C and overrides this particular method. And it has a sum method which has the same named arguments but in the inverse sequence, so it's y then x. And obviously it has new default values. And it actually just delegates to the parent. So it takes the values, it passes it to the parent, the implementation should be the same. What do we do then? We construct a new D, and we can keep the same D, but we assign it to a value of type C. So it's the same object, same class, instance, but once as a D, once as a C, and then we call it with x equals 0. And of course, y is, because it's default argument, it should work. And now, the sample answers.
Before we get into it, I'm just curious, how many people read Josh Surratt's Scala in Depth book, or attempted reading? Okay, good, because this one is taken from that book.
So Josh should get it right. Josh specifically supplied the very nice kind of mnemonic at the end that we will point out as a good way to figure out what's going on here. If you want to make lunch on time, then time is up now. Who thinks it's number 1? Who thinks it's number 2? Who thinks it's number 3? Who thinks it's number 4? Okay, so it's basically 1 and 4 were the kind of majority of the votes. So let's have a look.
So it seems that most people then missed it.
Finally, we fooled at least a few people. Wow. What's going on here? Well, there's the short form. Names are static, values are runtime. I'll briefly run through it so we can all leave on time. In the first case, we are calling it on C.
Do you maybe want to use this?
Oh, yes, I'll use so I don't have to wave my
it's gonna
finger
be
in the
easier,
air
right?
like poor Eric had to do in his keynote. And I have to figure out which button to push. This one. So in the first one, we're calling it on a C, even though it's a D object. What does this mean on a C? Well, it looks at, this becomes a placeholder for the first. It uses X from C, but that translates to setting the value of the first argument so that this one is passed through because the names are static. It resolves the position of the X from the type, the static type, even though at runtime the value that you need, the default value for the second argument comes from the runtime type, from the D. And in the second case, because you get what you expect because it resolves the position to default, the X from the static type, which is D, and the value from the runtime type, also 0. So you get this being passed in, this being set to 0. The result is that.
So essentially...
What? Sorry, should I do that one again?
No, let me try to summarize, because...
Uh-oh, we have an answer from the back again. That's an excellent question. Maybe we should ask Josh, or we should open it as a bug. It's a feature.
This works as
it's
expected.
Not a bug.
So... right.
Yeah, no, that's true. And the values actually come from default methods. They're methods that are generated on the thing. So they're going to work with overriding because you're basically getting an overridden method that's called to provide the default argument. But the names are done statically, exactly.
Right. So basically the entire trick is that in case of C, it really looks at that method sum defined in C to say, okay, I'm going to pass 0 as the first one. And then during runtime, it figures out, oh, it's that 0 that applies there. So as Josh said, names are static, values are runtime. It's just what you need to keep in mind.
And now values are lunchtime. Thank you very much. Let's just show the discount code again.
Keep going. Just to remember, ScalaDays 2014 is the discount code if you want to buy the book.